normal ECG placement and axis. Now let's go to points 4 and 5. These are both related to lead 1 of the ECG. Point 4 is looking at lead 1 and lead 3 together and making sure they are smaller than lead 2. As we mentioned earlier, the waves in lead 2 should be equal to the sum of the waves in leads 1 and 3. In other words, the waves in lead 2 should be more positive than the waves in lead 1 and lead 3. The equation is lead 2 is equal to lead 1 plus lead 3. If the P and T waves in lead 2 are smaller than those in leads 1 or 3, then this can indicate the electrodes were placed incorrectly and the leads can be reversed. So the ECG may need to be repeated after correct placement. Here are some examples of lead reversal. In the first ECG on the left, lead 3 shows larger or more positive P and T waves than in lead 2. In the second ECG on the right, lead 1 shows larger or more positive P and T waves than in lead 2. Since lead 2 should be larger than leads 1 and 3, the left ECG and right ECG may need to be repeated after correct electrode placement. However, even if the ECG done for a critical patient needs to be repeated, it is wise to look at the rest of the ECG while you wait for a new corrected ECG. This is because even a reversed ECG may still have other abnormalities that require your attention. Then after you get the recalibrated ECG, use the new one to confirm or deny the abnormalities in the previous uncalibrated paper. Now let's go to point 5, which is also related to lead 1. But this time, we will combine lead 1 and lead AVF. Remember that lead 1 is looking at the heart from the left shoulder and that a VF is looking at the heart from below or from the feet. This means that lead 1 is perpendicular to AVF. This 90-degree angle between both leads can help us detect the axis or the electrical direction of the heart. As we said earlier, as the current passes from the side, no atrial node to the apex, the direction of the current is downwards and to the left. So the normal electrical current of the heart moves at an angle between both perpendicular leads. It goes leftwards towards lead 1 and also moves downwards towards lead AVF. This means that lead 1 should see the current coming left towards it and draw a positive QRS wave, and the camera of VF should also see the current coming down towards it, and it should also draw a positive QRS wave. So normally, leads 1 and lead VF should both have positive QRS waves, and this represents a normal heart axis. Now let's see examples of abnormal heart axis in conditions that increase the size of the right ventricle, such as pulmonary hypertension. The axis of the heart shifts to the right, and this is called right axis deviation. But what does this even mean? As the right ventricle is larger than normal, more electrical current will now be moving towards the right side of the heart and lead AVF, but this also means that less electrical current will be moving towards the left side of the heart and lead 1. In fact, the current may be moving away from lead 1 altogether, that lead 1 draws a negative QRS. Therefore, in right axis deviation, as the current moves away from lead 1 and towards lead AVF, lead 1 tends to be negative, whereas lead VF will be positive. So in right axis deviation, as the QRS wave in lead 1 is negative and in lead AVF is positive, it appears on the ECG as if they are looking towards each other, as if they are attracting each other. What about opposite conditions that increase the size of the left ventricle? Well, in conditions enlarging the left side of the heart, like hypertension or aortic stenosis, which cause left ventricular hypertrophy, the axis of the heart shifts to the left, or left axis deviation. What does that mean exactly? The current will now be moving more towards lead 1, but will be moving away from lead AVF. Therefore, in left axis deviation, lead 1 will be positive, whereas lead AVF can be negative. And as the QRS wave in lead 1 is positive and the QRS in lead VF is negative, it will appear on the ECG as if they are looking away from each other or repelling each other. So we have now finished the first 5 points. The first 3 points, N, V, and S, were to know that the ECG belongs to the right patient and that it has been calibrated correctly regarding voltage and speed. Then points 4 and 5, lead 1 and lead 1, were to confirm correct lead placement and detect the heart's axis.